Hello, my lovely viewers. Welcome again to Mathematics and I. It is your favorite presenter, Jeff Nino, and today we have a question on the board which we are going to be solving. And if you take a look at the question very closely, you will notice that we have two right angle triangles here. The first one is ABD, and the second is ACD. Now we are told to look for line CD, which is x meters. Now the fact is this: how can we actually solve a problem that looks like this? Now there is no way we can go ahead solving x meters. From the start, it will be kind of difficult. So what we are going to do is this: let us try to separate the triangles given, and then we see how we can solve. Now first of all, let us solve with ABD, triangle ABD. Now if we bring this out, okay, A, B, and D, and then we have angle 90. Now we have here at point B, the angle there is 45 degrees. All right, and the hypotenuse is 5 meters. Now, what you are going to ask yourself is, which of these lines is common to triangle ABD and also triangle ACD? Now, that is not given. Now, the line is the height, which is line AD. So it means if I'm able to get line AD, I have also solved for line X. So let's see. Now, for me to get line AD, let us assume line AD is y meters. Okay, now how can we solve for y? Now, you will notice that in this right angle triangle, the hypotenuse we have 5 meters. The opposite we have y meters. But at the adjacent, we have nothing. So you would look at the basic trigonometry ratios, which are so, ka, twa. Now you will look between these three, which does not have adjacent. And the one that does not have adjacent is so, which is opposite over hypotenuse. So that is exactly what we are going to be using to solve for y meters. So using so, which says sine theta is equal to opposite over hypotenuse. Now our theta given here is 45 degrees. So here we have sine 45 degrees is equal to, now the opposite of 45 degrees is y, and the hypotenuse is 5. Okay, so now what do we do? Now 45 degrees is a special angle. And what is 45 degrees? Sine 45 degrees is the same thing as cos 45 degrees, which is 1 over root 2, or you can simply say root 2 over 2 when rationalized. So if we use root 2 over 2 as sine 45 equal to y over 5, what we have to do here now is to cross multiply. When we cross multiply, we are going to get y multiplied by 2 to give us 2y. Okay, now here becomes 2y is equal to 5 multiplied by root 2 gives us 5 root 2. Now for us to make y the subject of the formula, we have to divide both sides by the coefficient, which is 2. So if we divide both sides by 2, divide both sides by 2, now when 2 cancel out, so what we have now is y. Now it is wrong for you to say 2 divide this 2, because why? This 2 is inside the root. So what do we do? Leaving our answer in short form, let us take y as 5 root 2 over 2 meters, because 2 can't cancel 5. If 2 cancel 5, it takes us to the decimal what? Answers. Okay, now, if our height now is 5 root 2 over 2 meters, now let us solve for x. Now, for us to get x, we are using triangle ACD, the next triangle. So if we bring that out, okay, now the angle there is 60 degrees, and our, what's it called? Our height remains 5 meters. And then what do we have here now? Okay, sorry. Now, mind you, line AB is not common to triangle ACD. So it means there is nothing on the hypotenuse. So what we are working with here now is the height, which is 5 root 2 meters over 2. And then we're looking for x, which is x meters. Now we have A, C, and D. Okay, now why did I not use 5 meters? Because 5 meters is only common with A, B, D, and not with A, C. Look at it, AC has its own hypotenuse, and in line AC there was no hypotenuse given. Okay, so let's proceed. Now for us to get X, this is what we're going to think of. In this right angle triangle ACD, there was no hypotenuse given. There was nothing on the hypotenuse. So it means the basic trigonometry ratios which are so again, you will check which one does not have hypotenuse on it. And the one that does not have hypotenuse on it is 12, which is opposite over adjacent. So it means that in this part of the question, we are going to be using tan theta. So here becomes tan theta is equal to opposite over adjacent. Okay, now theta here is 60 degrees. Now tan 60 degrees is equal to the opposite now is 5 root 2 over 2. Now all over the adjacent now is x. Alright, so without wasting time, tan 60 degrees is also a special angle. So tan 60 is root 3. Just the way tan 30 is 1 over root 3. So if tan 60 is root 3, it means here becomes root 3 is equal to 5 root 2 over 2 all over x. So what do? Base root 3 over 1 and cross multiply. So when x multiplies root 3, we are going to get x root 3 is equal to 5 root 2 over 2 multiplied by 1 still gives us 5 root 2 over 2. Alright, so what are we going to do now? We're going to divide both sides by root 3 so that x becomes the subject of the formula. So here becomes over root 3 and here becomes over root 3. Alright, so if we do this, when root 3 cancel out root 3, what do I have left? X. Now mind you, when you say 2 over 4, it also means 2 divided by 4. Alright, so if I should say 5 root 2 over 2 divided by root 3, it can also be written as, okay, it can also be written as x is equal to 5 root 2 over 2. Instead of me writing all over, I will simply write divided by root 3. Okay, now we all know that the division sign will change to a multiplication sign, and hereby root 3 becomes 1 over root 3. It reciprocates. So here becomes x is equal to 5 root 2 over 2. Now division becomes times, and here becomes 1 over root 3. Okay, so if we proceed with this, we're going to be having this. X is equal to 5 root 2 over 2 multiplied by, if I should rationalize 1 over root 3, 1 over root 3 will give us root 3 over 3. 1 over root 3, if rationalized, will give us root 3 over 3. How did I get that? If I want to rationalize 1 over root 3, it becomes 1 over root 3 times root 3 over root 3 if I want to rationalize. And so 1 times root 3 gives us the root 3 at the numerator, and root 3 times root 3 gives us root 9, but the square root of 9 gives us 3, which is at the denominator.